Limit theorem states that the limit of a quotient as x approaches a is actually equal to the quotient of their limits. Okay? So, pwede pa nating paghiwalayin ito. Limit ng f of x over limit ng g of x. However, dapat yung limit ng g of x natin as x approaches a should not be equal to 0. Okay? So, pwede natin itong gamitin basta yung nasa denominator natin, yung limit niya dapat hindi 0. So, for purpose of illustration, gamitin natin to. Limit of 4x over 5 as x approaches 3. So, kapag tinignan natin yung denominator 5, we know that the limit of this exists. Kasi nga, constant lang to. Diba? So, pwede natin gamitin yung theorem number 7. So, we now have the limit of 4x as x approaches 3 divided by the limit of 5 as x approaches 3. This is now equal to, ano ito? Pwede natin gamitin yung theorem. Anong theorem? Theorem 4. Okay? So, ilalabas natin yung 4 times the limit of x as x approaches 3 all over, ano ba tong limit na to? By limit theorem number 2. So, limit of a constant, this is equal to 5. Okay? So, we now have 4 times, ano ba yung limit of x as x approaches 3 by theorem 3? So, that is just equal to 3 over 5. So, the answer now is 12 over 5. Again, for purpose of illustration, let's find the limit of 6x over 11x as x approaches negative 2. So, let's check kung yun bang nasa baba niya ay, yung limit ba nung nasa baba ay not equal to 0. Okay? So, check muna natin if limit of g of x as x approaches a is not equal to 0. So, that is the limit of 11x as x approaches negative 2 is equal to, so that is now the limit of x as x approaches negative 2 times 11 kasi nilabas natin yung constant. So that is now 11 times negative 2, so which is negative 22. So, since the limit of the denominator is not equal to 0, then we can use theorem number 7. Okay? So, theorem number, limit of 6x over 11x as x approaches negative 2 is now equal to the limit of 6x as x approaches negative 2 all over the limit of 11x as x approaches negative 2. So by theorem 4, this is 6 times the limit of x as x approaches negative 2 all over the limit. So ilabas muna natin yung 11. 11 minus times the limit of x So this now becomes 6 times the limit of x as x approaches negative 2 all over 11 times the limit of x as x approaches negative 2. So we now have 6 times the limit of x as x approaches negative 2 is negative 2 all over 11 times negative 2. So the answer now is 6 over 11. Theorem number 8, it says that if the limit of f of x raised to n as x approaches a is actually equal to, kunin muna natin yung limit ng function, then saka natin i-raise to n. Okay? Note that if n is less than 0, ibig sabihin, yung n natin dito, yung naka-raise dito ay negative, then, yung limit dapat natin is not equal to 0. Okay? So, let's take a look at this example. The limit of x squared as x approaches 12. So, by Theorem 8, pwede nating gawing limit of x as x approaches 12 raised to 2. So, by limit theorem number 3, this is equal to 12. Okay? Raised to 2. So, the answer now is 144. Next example, if we have the limit of 3x raised to negative 3 as x approaches 5, so we now, labas muna natin, the limit of 3x as x approaches 5, lalabas ngayon si negative 3. Note that, yung ating n dito ay negative. So since negative siya, anong mangyayari? Magiging isa siyang fraction. Tama? Okay, so we now have, ano bang limit na ito? So by Theorem 4, that is 3 times the limit of x as x approaches 5 raised to negative 3. Or we have 3 times 5 raised to negative 3. Okay? Or that is now equal to 15 raised to negative 3. And we know that 15 raised to negative 3 is equal to, dito na tayo, 1 over 15 raised to 3. Okay? So the final answer now is 1 over 3,375. For the last theorem, the limit of the nth root of a function as x approaches a is actually equal to the nth root of the limit of f of x as x approaches a. So, pag meron pala tayong ganito, pwede pa nating ilabas yung root, nth root niya. Okay? Kunin muna natin yung limit ng function and then saka natin nth root. Provided that yung n natin dito must be an element of the set of integers. And dapat yung limit natin dito sa loob, greater than 0 dapat siya if n is even. Tama naman, di ba? If we have square root of 8, so merong value yan. Pero kapag square root of negative 8, wala, imaginary. So dapat kapag even siya, positive dapat yung nasa loob. Kapag naman n is odd, so kahit ano yung nasa loob pwede. Okay? So let's consider this example. The limit of the fourth root of 8x as x approaches 2 equals, by Theorem 9, pwede nating ilabas. So yung fourth root of the limit of 8x as x approaches 2. Okay? So we now have the fourth root of 8 times the limit of x as x approaches 2. So again, that is fourth root of 8 times 2. Or that is fourth root of 16. But what is the fourth root of 16? That is equal to 2. So consider the example, the limit of the cube root of negative 24x squared as x approaches 3. So pwede nating ilabas cube root of the limit of negative 24x squared as x approaches 3. So this becomes the cube root of negative 24 times the limit of x squared as x approaches 3. Then we have the cube root of negative 24 times, ito, pwede nating gamitin yung limit theorem number 8 natin. Okay? So, x as x approaches 3 squared. So, what is this now? This is now 3 squared. Tama? Ito by theorem. Anong theorem to? Theorem 3. Okay? So, we now have 3 squared. So, that is 9 times negative 24. So, that is now the cube root of negative 216. Negative yung nasa loob. However, yung root natin is odd. So, pwede. Okay? Okay lang to. Okay? Meron pa rin tayong makukuhang root dyan. And the answer is negative 6. So, in summary, limit theorem 1 states that the limit of a function is unique. Okay? So, iisa lang dapat yung limit. Hindi pwedeng pareho yung function, magkaiba sila ng limit. Then number 2, limit theorem number 2 states that the limit of a constant is itself. Okay? The limit ng constant as x approaches any a is equal to itself. Limit theorem number 3 states that the limit of x as x approaches a, eto gagawin mo lang, substitute mo lang si a kay x. So that is a. Limit theorem number 4, pag meron daw tayong limit ng constant times a function as x approaches a, pwede nating ilabas yung constant tapos kunin natin yung limit ng function and then multiply. Limit theorem number 5, yung limit ng sum or difference ng 2 or more functions, okay, 2 or more to kahit ilan yan, as x approaches a, is actually pwede nating kunin yung limit ng individual functions. And then we add or subtract, whatever man yung operation. Limit theorem 6, sinasabi naman nito na yung limit ng product of 2 or more functions, okay, so 2 or more functions ito, limit 6 naman states that the limit of the product of 2 or more functions, so kahit ilang function pa yan, as x approaches a is actually equal to yung individual na limit nila na pinag-multiply natin. So that is the limit of f of x as x approaches a times the limit of g of x as x approaches a. So note that this is true kahit na ilan pang function yung pag-multiplyin natin. Limit theorem number 7 naman, sinasabi niya na limit ng quotient as x approaches a is actually equal sa quotient ng individual limits, provided that your limit in the denominator should not be equal to 0. Okay? Siyempre alam naman natin yon, basta rational function siya, dapat this is not equal to 0. Limit theorem number 8, pag meron tayong limit ng function na ni-raise sa isang integer, so as x approaches a, so pag meron tayong function na ni-raise sa isang integer at kinukuha natin yung limit, pwede natin actually kunin yung limit ng function na yon and then saka natin i-raise doon sa integer na yon. And finally, limit theorem number 9, pag meron tayong limit ng root, nth root ng isang function, so pwede nating ilabas yung root and then kunin yung limit ng function natin. Okay. Provided that, again, dito, kapag even yung n natin, dapat yung nasa loob ay positive. Okay? Kapag even ito at negative yung nasa loob, therefore, the limit does not exist.